History of Windmill 1. Ancient Persia, circa 7th century AD. The first windmills were likely developed in ancient Persia, modern-day Iran, where they were used for milling grain and pumping water. These early windmills had a vertical axis design and were quite different from the horizontal axis windmills we are familiar with today. The Persian windmill was crucial for irrigating lands in arid regions. 2. Medieval Europe, 12th century. Windmills began to appear in Europe during the medieval period, especially in the Low Countries, modern-day Netherlands, Belgium, and parts of France. These windmills were typically used for grinding grain and draining water from low-lying areas. The design of these windmills evolved with the introduction of the horizontal axis windmill, where blades rotated around a horizontal axis, making them more efficient for capturing wind energy.
3. Innovations in windmill design. Windmill technology in the Netherlands. The Dutch are often credited with advancing windmill technology in the 16th and 17th centuries. They made improvements to the blades, mechanisms, and the ability to control the direction of the windmill, allowing for more efficient operation, especially in water pumping and land reclamation. Invention of the smock mill. 4. 19th century development of wind turbines. The windmill's evolution continued into the 19th century with the development of the first wind turbines that could generate electricity.
The processes of a windmill, especially in the context of converting wind energy into useful mechanical work, involve several stages. Here's a breakdown. Now we will discuss step by step of windmill procedure. 1. Wind capture. Windmill blades or sails are designed to catch the wind. As wind blows, it flows over and under the blades, creating a difference in pressure. This pressure difference causes the blades to move, converting the kinetic energy of the wind into rotational mechanical energy. 2. Rotation of the blades. The blades of the windmill rotate around a central axis. The force of the wind on the blades turns them, which is the primary motion that drives the entire system. The rotational movement is transferred to a shaft connected to the blades. 3. Mechanical work, depending on purpose. For grinding grain. In traditional windmills, the rotating shaft can drive a millstone. The millstone grinds the grain into flour by crushing it between two stones.
4. Transmission of power. Transmission of power. The rotational energy from the blades is transmitted through gears or shafts. The power from the blades can be directed to various types of equipment depending on the purpose. For modern wind turbines, the mechanical energy is transferred to a generator where it is converted into electricity. 5. Energy conversion for modern wind turbines. Wind turbines. The mechanical energy from the rotating blades is connected to a generator. As the shaft turns the generator's rotor, mechanical energy is transformed into electrical energy through electromagnetic induction. This electricity can be stored or sent to the power grid for distribution. 6. Control systems. Modern windmills, wind turbines, often have control systems that adjust the angle of the blades, pitch control, to optimize performance based on wind speed and direction. In traditional windmills, the direction of the mill may be adjusted manually or with a vane to face into the wind.